Hello there, I'm Mark, and welcome to my Unreal Engine tutorial on how you can manage all your character core vital data within your game. In this tutorial, I will be building out a little actor component that can be integrated into your character's classes, and which can be able to manage your core vital data. And I will just fire this up to show you what we're talking about. So as you can see, I've got some health bars, stamina bars, sustenance, and energy. And within this, and it's all being managed within my little core vitals manager component. And as you can see, as the health goes up, we can do regeneration. Then we have sustenance and energy, which are all being deprecated over time. Also within this tutorial, I'm going to also make so that we can also save. And make sure that our component is save system ready, so we can then save it and then reload it, save it again. And also, for fun, we'll add a couple of little rules into our component. So say if our sustenance reaches 0, i.e. we're now starving, it will now heavily impact or start to negatively impact our health. We can also put the save system in there again. But rest assured, we can also reverse it by feeding our character, giving our character more energy again. And then if we wanted to, we can then go into reloading it, get back to its previous state, saving, and then reloading. So this system will be also, ready for saving and loading within your character as well. So it should be a pretty complete system that you can use. So without further ado, let's get started. I'm just going to stop that. So I will be building the component out in C++. And to save a little bit of time, I've already went and created the component here within the editor. So all I did in order to do this was to go and bring up Unreal Engine. And within there, we would just go ahead and select the game. We'll select games, third person, C++, desktop. I like to go scalable, no starter content, no ray tracing, and then go ahead and give it a name that you like. I'm just called mine, Core Vitals. Manager, but you can call it whatever you like. So once that happens, it will pop up a solution. Give it a little bit of time. It is C++, so it does need to compile the code and the application, so it will file. But from there, what we'll do is we'll get our content, which is our characters, levels, and prototyping. This is all of our script content, and it'll add the C++ classes as well. And since we're using the third-person template, we'll also get 2 extra classes: the Core Vitals Manager character, which is the character you saw in the game, as well as the game mode. For this tutorial, we won't be doing anything with this, but we will be, we'll just go ahead and just script it into the blueprint here, which this blueprint is inheriting from these classes. So let's go ahead and get started. So I'm just going to go ahead and create our first piece of code. So the way I like to do things is I like to kind of take a bottom-up approach. So what we'll be doing is we'll be defining what a core vital is, and then from within there we'll then define what that group is, which is the character vitals, which is just a group of core vitals, which can be there, and that's all again data structures. So this will be our data architecture, and then within that we'll then take that and then have the actor component that we'll then be building, be used to then manage that. So let's go ahead and get started. So the first thing we're going to do is we're going to hit new class. So out of the box, Unreal Engine doesn't give you the ability to create a struct. And that's what we're going to be using to manage our core vital data. So but what we can do is we can take a basic generic template like this. We can go give it a name like core vital, and we will change this into a struct that we can then use. So I'm going to call this core vital. So this is our basic unit, and we're going to hit create, and we're going to let it do its thing. And as you're going to see, this is going to go and fail to compile. Oh, today I decided to work. So it's gone ahead and compiled. We're going to bring up our core vitals. We're going to say save as. It's going to save all the information. And as you can see right now, we've got our core vitals. And this is a class. This is not exactly what we want. What we want to do is we want to convert it to a structure. And that's pretty simple. So what we can, let's go ahead and do that right now. So the first thing we want to do is go ahead and add the core vital generate.h. This will then create create that generated object based off what this is. And then so that we can access this, this soon to be structure within the editor, we'll go ahead and add the struct and set it to blueprint type. We're going to change it from class to struct. And we're going to go ahead and give it a prefix of f, since all structures within Unreal Engine have an f, so we'll keep the naming convention going. And so now what we need to do is we're just going to go ahead and change those implementations real quick. And now we have the basics of our core vital. Now, as you can see, our core vital structure doesn't really do anything. So let's go ahead and change that. So first off, we need to define what is within our core vital. So, before we do that, I just forgot, we also need to add the generate body macro. So that will work. Yeah, it's there now. So let's go ahead and build this. So first off, we need to have some basic data attributes. So the first one we're going to do is we're going to say, okay, property is the current. So what is our current health, stamina, sustenance, you name it. So we'll create a variable called current. I'm going to give it a default of 70. That way we can just make sure that it's recharging. But you could probably give it a default of 100. It's up to you. We're going to make this. We're going to make it a U property, defined as a U property, so it can be seen within the editor. And also we're going to set some attributes. So we're going to say edit default only, we're going to make it blueprint read only, and we're going to go ahead and give it a category just so that we can make it look nice and neat. Next up, well, we have a current, but like in any other video game, we also need to have a max. And this is kind of like a soft constant, right? This is kind of like the our max health, but in a lot of games, we like to then, as you level up, you might want to increase your max health, so we don't make this a constant, but it's a variable. So again, same idea, default only, blueprint read only, and category is core vitals. I'm going to call it max. We're going to give a default of 100 for now, but that can get incremented over time, over the life of the game. Something I like to do is to create modifiers, especially when we're dealing with like max, these things which are like soft constants, right? I don't like to modify the actual maximum variable if it's something that's going to be it's like if it's like a game buff or a debuff. So that's where I like to use the concept of the modifier. The modifier is what we actually change, but we don't change this. That way, when the debuff comes off, we don't have to worry about what the actual max was again, because that will always be set here. Since we're now going to be, we want to have the concept of generation and regeneration for some of these things, then we're going to create a generation amount. So this is how much we're going to deprecate over time for this particular vital. We're going to set the default for 0.2. Again, edit defaults only, category core vitals, and then we're going to call this generation. I like to call it generation because this could be how much we're going to increment by, but it could also be how much we can deprecate this particular variable by, depending on how we want to set things up in the core vital manager. Next up, we're going to bring in another variable, which is our modifier. So again, this is how much we're going to be generating over time, but we could take a potion, or we could have a spell which could allow us to, or a buff which could give us a buff or a debuff. So we don't necessarily want to change the actual raw figure, we'll just use the modifier instead. And then just so that we can make this thing a little bit easier to use, I'll give it a nice smooth, regeneration or deprecation or degeneration over time. We can use this wants to generate flag variable to allow us to say that this thing can actually regenerate or not regenerate over time. So after that, let's go and define our, we're going to define our constructors. So we have the default constructors right now, but just to make things a little bit easier, I'm actually going to go and add in here another constructor, right? And this is just going to give us current, max, generation amount, and whether we're going to be able to generate, right? And this one's always, and by what we'll do here is by default, if it's not defined, we'll make it true. So that's under core vitals. So next up, something that I like to do on my structures is to start putting the business rules in as well. So let's go ahead and do that as well. So I'm also going to say these are our game rules. So first off, we want to have a way to increase the current amount. So we'll create a little public function that if you put an amount in, it will tell us how we want to increment it. We're also going to do the same thing for increase max. We'll go ahead and do one for increase max modifier. And also for us to be able to decrease the max modifier as well, since this is a variable that can go up and down, where increase max can only ever go up. We're also going to write a little function which will allow us to get the max modifier, and this is something that will be used, within some of these other functions as well. Because we want to output this into a UI and into a progress bar, we'll also want to get the percentage version as well. So we'll go ahead and do that. Another little thing that I'm going to add is, do we have enough? So this is a little, so some games where you have stamina, you may have magic or a mana, where you might want to, if you're trying to cast something using magic, you might want to check to see if you have enough in there before you actually do the cast. So what this does is it will go in, you'll put the cost of how much you want, and it'll check to see if you actually have that in the bank. And if you don't have it in the bank, it'll come back false, and if you do, it'll come back true, and then you can go ahead, cast it, and then run the deprecation. Some other little helpers is full. I like to put in there is empty. We're also going to add the decrease current. We're also going to bring over regenerate, the rules for regeneration, and we're also going to head and bring in the rules for depletion. And as you can see, everything, increase, the increases, the decreases, the decrease current, these are all done by amounts, but regenerate and deprecate, that's done over time. And so we'll be putting a delta time in there to help manage that. So these are all our methods that we're going to be adding into our structure. So this is now a complete unit. And so let's go ahead and start implementing these functions. So first off, we'll go ahead and implement our second constructor. So what we'll do is we'll set current. So here we'll go ahead, set the current, max, generation, amount, and generation. So this just goes ahead and just creates a nice way for us on construction of any core. When we run the constructor, when we create a new core value, we can just go ahead and just add these values right in off the bat. We don't have to we don't have to manipulate anything through any, keeps it nice and neat. So then increase current. So let's go ahead and create the increase current. So this is the rules on how we will be increasing the current amount. Right. Next up will be increase the max. So let's increase the max. And some of these are just very simple little functions, but yeah, they're nice, they're all reusable. And next up is increase the max modifier. So here we have a couple extra rules. So we'll increase the modifier, but then we'll check our current max and if our max. And as you can see, we're now also calling in another function, which is get max modifier as well, just to kind of keep things nice and neat. And so as you can see, as we do the max modifier on the max, we also want to update our current as well. So this gives us a nice little reusable, piece of logic. We're also going to go ahead and bring in the decrease max modifier, and I'm just copying and pasting everything from a solution that I already built, since I don't think people would like to see me type, and my spelling is god awful anyway. So max modifier, same rules. If current is greater than get max modifier, and then current is equal to max modifier, you can go ahead and do that, and that should set things up nice and neatly. We're going to come back and we're going to say get max, get modify max, and this is a function that you've seen kind of up here. Now we're actually going to go and put the implementation of what that actually does, and all that does is it just says, we're just going to get the max, we're just going to go and add the modifier to the max and just return that, and that's what we're doing. Real simple. Get current percentage. Again, this one is a real easy one. We're just going to say get current, and we're just going to divide it by get max modifier. That way we actually get the real one and not just the max. Next is enough. So we're going to go ahead and check to see if we have enough, do the enough check. We'll run that there. Current is greater than cost. Pretty simple logic. Is full. Just going to go ahead and bring this one out. So current equal to modification or max modifier, or modified max, whatever you want to call it, is empty. We're going to bring this one up. Pretty simple rules, but they're all reusable. Now this is what decrease current. We've got some specific rules in here that we want to do to make sure that we get a nice clean, when we do start to decrease it. So there's current amount minus current equals current, and then what we do, so with decrease we're going to return a boolean, and the reason why I like to return a boolean here is that if this returns true, it means that we died. If it returns false, it means we still have a little bit of health left in us. So we'll do a quick check to see if current is less than or equal to 0. If we are less than 0, then we'll always set to 0, because we can never have negative health or negative something, well, for the most part. And we'll return true. So what we've done is we're now set to dead. Or if this was health bar, it would be dead. If this was something else, it gives us a quick flag to say that, hey, we've run out of whatever we're decreasing. And then the last two have to deal with regeneration and depletion. So we'll go ahead and put those rules in. So again, as you can see, we have a flag called wants to generate. This will allow us to turn off or on within the vital itself whether we're going to regenerate or not. So as you can see, if wants to generate, if this is set to false, we're just going to go ahead and return, and we won't even run any of this code. But if it's set to true, we'll come in and we'll then go ahead and run the regeneration. And we will then do the same thing for deplete. So I'm just going to go ahead and do that. And this is just the reverse. Instead of adding, like we do with regeneration, we're just going to go and subtract instead. So very similar rule set, and it's the same idea. We can turn this on or off based on, at the value, at the variable level. So that now gives us our core vitals. So we have structure, we have the definition, we have a bunch of helper functions or methods, depending on what you like to call them, and then we actually have the implementation. So that looks like we're good to go. So that's the basic unit of what a core vital, or what I like to call a core vital. So now let's take this up to the next level. And to do that, we're going to create another function, and this will be the character vitals function. So before I do that, I'm just going to make sure that this thing compiles and everything, and Unreal Engine is happy. And yes, Unreal Engine is happy with the compile. So let's go ahead and create that next structure. So with Unreal Engine, it doesn't seem to, when it goes ahead and adds structures into a folder, it doesn't seem to like to show the structures. It will show classes, but it won't show structures, but the structures are there. So we're going to go ahead, add a new class. I'm going to come in, I'm going to hit next. And then we're going to call this character vitals. So this is the next level up, and this will define that package of vitals and kind of group them together into a higher level structure. So let's go ahead and create that class. And it's going to do its thing. It's going to go through, it's going to compile, and we're going to come up, we're going to say reload, and as you can see, it's a class. We don't want the class, we want the structure. So we need to do a couple of things here. So we just created this thing called core vital, and we want this structure to be able to use it. So let's go ahead and put the include in there. So that's where our core vital is. As you can see, everything's, I'm using a very flat folder structure right now. Ideally, we'd probably want to, group things out into smaller folders, but for this demo, it's just one component. So we'll just keep everything together. So we'll go ahead, we've got the core vital. So let's go ahead and turn this into a structure, from a class to a structure. So first off, let's go ahead and put the decorator on there. Let's go ahead and reclassify this as a struct and give it the prefix that Unreal Engine likes to use. And let's go ahead and put the macro to generate the body in there, and let's not forget the include that we need to do. So core vitals.generate.h. I like to put a little space between any of my include, h.h file includes and the generate, because within the header file, nothing can be below this. This has to be at the bottom of your include stack. So I like to keep a space there. That way I know that there is nothing there and it doesn't get lost. It's just my personal preference. Let's go ahead and change these over. Let's go ahead and wipe those out since we're not going to use them. And let's go ahead and start defining what makes up a character vital. So something that I like to do, and you see it in a lot of video games, is concept of essential and protected. So we're going to go ahead and add that into our character vitals component. So this will help us define whether a character is essential to the game and whether it's to a game, a quest, and then we also have the is protected as well. So is protected, this means that the character may or may not be killed, whereas essential means that a character, if you have this in, say, an AI, that way your AI can, if your AI drops below like 10 health, we will keep it at 10 health, so you can create the concept of a downed character. So we've gone ahead, we've done that, so that will help that out. We're going to add the concept of simulation mode, since this is kind of a reusable component that can be used both for players and AIs. So for AIs, you may want to use the sustenance and energy variables to determine whether an AI is, hungry or it wants to sleep. But you could also use that simulation mode for if you wanted to do a survival-based game in which your character has to eat and has to sleep, and if it doesn't, it gets negative. Because I call it simulation mode instead of survival mode, only because we can use this component can be used for both players and AIs alike. We're also going to create the is dead flag. So this will allow us to know. This will say if the character is dead, it really is dead within the components. And then the other thing I like to do is we're going to set the regeneration time. So we're going to be using since we're going to be using a timer, a concept. Everything here is a function of time. We need to then define what that function of time is. So this is now going to say by default, and our generators or regenerators are going to run every 0.2 seconds. And we'll then, and this is what we will use within the actor component to determine how often we're going to refresh our progress bars. All right, after that, now we can start talking about all those vitals that we just created. So we created that nice structure. Let's just start bringing it in. So the first one, again, here's our health structure. Here's the structure that's going to be managing our stamina. And here's the structure that can be managing our energy. And here's the structure for this demo, we'll be managing our sustenance. And if you want to add more, it's just as easy as just, bringing this in, giving it another name, and hey, you've got another vital that you can manage within this framework. So let's go ahead and we're just going to use the generics for the constructor and for the destructor. So let's just go ahead and do that. And there's nothing else that we need to be adding in here at this time for the concept of a character vital. So that's our character vital. And as you can see, it feels a little bit like one of those Russian nested dolls. We've got the core vital, and then we bring it up to the next level, which is now the character vital, which defines more information and helps to group this information. So now, after all this is done, now we get to go ahead and build the actual manager that will help us manage all of that data that we've been creating. So first off, let's go ahead and make sure we get a good compile before we go ahead and add the next component. Yep, we got a good compile. Now we're going to go, so now let's go ahead and add the actor component that's going to manage all this. So let's hit new class. We're going to make this a actor component. So I'm going to scroll down, find your actual components. We're going to hit next. And we'll give this a nice name. Let's call this a core vitals manager. Actually, we'll call this core vitals component. So we'll call this the core vitals component. This is the component that's going to manage all of our characters' core vitals. So we'll go ahead and create this class. Now this is going to be a class. We'll let C++ do its thing. compiling, and since this is a class, you can see it's got, the Unreal Editor's gone ahead and recognized it here as being a class. So let's go back to our core vitals. We're going to go ahead and hit reload, and this is all the boilerplate code that has been created for us. And as you can see, we've now got our no, we don't want that. We've now got our core vitals manager, and it's inheriting from uActor component. So this is our core vitals component. So let's go ahead and implement, implement the code that's going to make all of the functionality that you saw in the demo at the beginning of the video work. So to do that, we need to do a couple of things. First off, we need to have a include. And we want this to be to our character vitals.h, which is the character vitals that we're going to be using. So this component is going to have two functions. Since we have a lot of core vitals that we want to manage, we don't necessarily want to have every single method defined within the component. So one of the things that Unreal Engine doesn't do when it comes to structures, as you know, if you've been working with the blueprints, you can create a blueprinted structure, but it's just purely structured data. It doesn't have any methods. And as you can see, when we created the structures, we didn't create any add any U function decorators because structures within Unreal Engine don't seem to support it. They do in C++, but in Unreal Engine C++, but they don't support it in the editor. So to do that, this component's going to have two functions. It's going to act as a service to service the data over time, but it's also going to act as a facade so that we can work with those functions that we've created on the structure and give us access to those from the editor. So we could do this one of two ways. We could just write all of those methods out and duplicate all of that code, but that gets kind of messy. The other way could be that we could then aggregate that by using an enumerator. So we can create a generic, use the enumerator to determine which one we actually want to access, and that will then help. That will help keep our code a bit cleaner, and also a bit more scalable if we decide we later on want to add some more vitals into the core management. So to do that, we'll go ahead and create our enumerator. So to do that, we'll just go up here. We'll just add the enumerator straight to the component. So we'll decorate this as an enum, blueprintable, so we can see it, so it can be seen in the editor. We've given it a name called core vitals type, and we'll go ahead and call we'll go ahead and create the enumerations. So under here, we've got some metadata for display names. This is all so that we can have a nice, easy to view. So it can be nice and easily viewable within the editor when we bring it into the editor, and we want to access this through the editor. So CV health, CV stamina, CV sustenance, and CV energy. This keeps it nice and unique by using a prefixer. We'll go ahead and save that. Next, let's go ahead and define the signature of our core vitals component. So one of the things we're going to do here is we're going to go ahead under the protected values. I'm going to go ahead and create our core vitals class. So we created the include to include the structure. The structure is now there, and we have this character vitals. And it's again default defaults, edit defaults only. It's read only. And we've made this a category of vitals. And I'm going to be putting all of these under protected. So as you can see, as the code's been generated, we have public, protected, and then public again. So protected, public means it's accessible from any. If you're not familiar with the concept of public, private, and protected, there are the 3 stages, and I'm not really going to go into the subtlety between protected and private. Only to say that if we put things underneath the public, then it's accessible to everything that has access to to this component. Where if it's protected, those methods or those variables can only be accessed within the context of the component, and so it kind of protects allows us to protect that information from any external sources. So we've gone ahead and created the component. We've got the generator. So let's go. Now in this, when you saw the demo, right, we had some nice little business rules in there which allowed us to say if we get below a certain value of sustenance, we're going to start hurting our health. We also might want to understand the concept of if we ever get to the point where the character is dead, well, we might want to then zero out all of it because the character is now dead. So let's create, so under protected, we'll create the game rules. And so for this demo, we've created some pretty simple rules. We've got on death. So this is what happens where if we suddenly get to a point where we have 0 health, we will then call the on death, which will then go ahead and clean our component up. We're going to have another function or method, depending on what you like to call it. And this is the regenerate vitals. This is the function that will be executed within the tick component that will allow us to update both the health, the stamina, as well as update the deprecation of the sustenance and the energy. We're going to also add a function to decrease the health because we want to have some rules in there. So if our health gets to 0, we then want to call our on death function to zero it out. We're also going to add another one called decrease sustenance, just some simple implementation rules there that we can add in, and then we're going to run our deplete sustenance. This is a function that's going to help to maybe override, which will have some rules in as we decrease what we're going to turn on and off based on that information. So that's everything that's going to, these are all of our rules, functions that we're going to put in, and they're under protected. So now let's go ahead and create the public signature side of this. So we've got on tick, so that's the tick function. So every time this component ticks, it will execute something within the loop. For now, we're just going to leave that as alone, but we will add our code in there soon enough. So 2 things that I'd like to add to this is we're going to add we're going to add a getter and a setter to our function, and the getter is going to be blueprint pure and the setter will be blueprint callable. So we can make this, anything which is a getter, I like to use as a getter, can be made a pure function because it's returning something, but if it's not returning anything, then we have to use blueprint callable. And adding these decorators just means that we can get access to this within the blueprint. So we have a getter and a setter because I wanted to make this save system ready. So this component, we can now set the data and reload the data from a save file. And to do that, we can do that all in one without having to run any extra code by just taking this data out and serializing it and deserializing it as needed. So that's what these 2 functions are for. And since they're just simple little getters and setters, we're just going to use the force inline macro to say that this is now a forced inline, and so we don't have to worry about putting this into the implementation file, which is sitting over here. So it's defined right there, and Unreal Engine will be should be happy when it's compiled. The next thing we're going to do is we're going to add a start timer. So this will actually allow us to actually start the timers that you saw. So what we don't necessarily want to do is we don't want to start this component's tick events if the data hasn't been loaded, right? We want to make sure that everything's loaded, everything's good to go. And then once the character is all good to go, and everything's been loaded in, or, then we can go ahead and start this. So this will help to give us a nice clean starting reference without having any ugliness at the beginning when we start playing the game. So next up, this is where we're gonna start adding some of our facade implementers. So as you can see, we're gonna say, well, we want to know, is something full? So this is where we're gonna start using our enumerator to determine what we pull back. So we have is full. We're gonna run the is empty and the same thing by enumerator type. I'm going to execute the is enough. And again, these are all going to be pure functions since they return. We're also going to add our increase current. And we're going to also add our decrease current implementer. And then after that, set regeneration flags. This will allow us to turn on and off our regeneration as needed. And we can also say get the %, and that's also by our enumerated type. And then to round things off, we're going to add some more forced in lines. So set is protected, so this will allow us to set the protected zero. So is essential is a flag that once it's set, it can never be unset, but protected can be set and unset based on the needs of the game. So you could have it that you may need to have a character be protected for a short period of time, but after whatever has happened in the game, you might want to then unset that flag. So now the character, and this is usually again for if you want to use this component to manage your AIs as well. So we can set the protected value. We are going to also say is dead. This is just a return value, so we're going to go into character vitals and pull that back as is dead. And again, forced in line, it's just a getter. And to round things out, we're going to have the is protected. It's the same idea. So we have the setter, this is just the getter, and all it does is it just brings back what the value of our protected value is. So that's pretty much the signature. So let's go ahead and add the implementation code. So our component will actually do some work. So to get started, we're going to go over to here. So the first thing we're going to do is, so here's the constructor, right? So as you can see, we have this primary component can tick ever and it's set to true. And we're going to keep this value at true. So, and as you can see from the comments, you may have a component where its tick component doesn't do anything, right? You don't have anything defined here. So if you don't want the component to tick ever, you can set that to false. And at that point, this will completely get ignored. It won't fire. And so it's good for optimization purposes. But if we want this to tick over time, we'll set this to true. But we don't necessarily want this thing to tick at the beginning. So to do that, we're going to say set component tick enabled, right? And we're going to say false. So while we can tick, we're just going to say that this is not going to be ticking until we're ready to tell it to start ticking. So done. As far as begin play, we're really not going to do anything within begin play. It's pretty generic. at this point. So this is, called during the finalization of the component. So we'll just leave that alone. And then we'll start to go ahead and work on some of our implementers. So on death is the first thing we're going to do. So we're just going to go ahead and create that. There's our on death. So within here, we're just going to say, first off, we're going to go create our character components. And then what we'll do is we'll also say that if this character dies, just to keep things a little bit more optimization friendly, we'll set our component, set component tick enable, just set that to false. Again, once it's dead, we don't need to keep ticking anymore. Once our character is dead, or the AI character is dead, we don't need to keep ticking this having this tick anymore. We'll just keep this as is. So I'm going to save that. Next up is we're going to regenerate our vitals. So this is what will happen within the regeneration loop. So here we're going to do something a little different. So this is how we're going to generate our code. So within here, we're going to add our 2 regenerators, which is our health and stamina. So all that is its character vitals, the health component of character vitals, and then we're going to call the regenerate function on that, and then we're going to set that by the regeneration time. And we should be good to go there. And then what we're going to do is we're going to have the other 2 functions, and we're going to run those which is part of our simulation mode. So again, character vitals is simulation mode. So it's a flag that we're set, and then we've got character vitals dot energy, using the dot concatenators, energy. We're going to call the deplete function, and then we're going to run character vitals, and then we're going to run the generation timer, and then the same thing here. And now the difference here is that we're for sustenance, since it's not as straight, since we want to have a couple of rules in there that if our sustenance gets to 0, we want to then negatively impact our health. We're going to be calling the deplete sustenance function here, and again we're going to just pass that in by the generation time that we're going to define when we go ahead and integrate this into our component. So next up, decrease health. So this is very important when we start losing our health. So what we'll do is we'll just go ahead and call this. So as you can see, as you know, we've got the concept of protected and essential. So the first thing we're going to do is we're going to check to see if this character under its core vitals component is either protected or essential. If it's protected and or essential, and then so we're using the or. If one of these 2 is true, we will then go into this mode where we will check to see if we have enough. If we have enough health in there, we will go ahead and decrease the health amount. So otherwise, if we don't have enough, right, we'll just go ahead and set the current to straight to 10. Keep it flat. We don't need to worry about it, and then we will return. Because now if this is false and this is false, this means that it's neither protected or essential, so we'll just let the chips fall as they may. We'll execute decrease current, and then if decrease current returns true, it means we're now dead, so we'll then run our on dead functionality, which will then go ahead and flag us as dead, 0 out our health, stamina, energy, and current, and then turn off our ticking within the components. And so that's what that will do there. So decrease sustenance, let's go ahead and pull this one up. And that one is a pretty simple one to run. we're just going to copy this and we're just going to paste that one in there. So this one's, again, the rules are character vitals dot sustenance is enough. We want to check to see if we have enough sustenance. If we don't have enough, then we'll go ahead and health decrease. You know, so this is again using the is enough. So if we don't have enough, you know, that's when we'll start to decrease our health. And by default, you know, for this demo, I've just set this as 2. You could make, I'm just hard coded it. You could make this a variable if that's something that you want to do in your code. And then we have the deplete. And then we have the deplete sustenance, which is how we want to execute within the loop. So just make sure we got it. So this one again, as you can see, is going to be called in regenerate vitals, and the regenerate vitals will be added to the time loop. So this is how we're going to be executing the sustenance within the time loop. We're going to go ahead and deplete it. Then we have core vital sustenance. If this is less than 1, that's we're going to say wants to generate. This is where we decide to turn the generate off. This will give us the ability to see that nice clean, you know, the health going down without the ability to come back up again. And we'll go ahead and decrease the health by, you know, again by 0.2 over time. So that sets us up for all of our game rules. So, and now we'll move over to implementing all of our functions here. So first off, let's go into the tick components. This is where all the business happens. And that's pretty simple. All we're going to do is we're just going to call our regenerate function. So regenerate vitals. All we're doing is just going to tick that over time. So every whatever second we're going to be ticking that, it will then tick by, it will generate the vitals. Next up, start timer. So this is where we actually want to start things, and we're going to do 2 things here. So we could use a timer, but since we're doing this in the component, in a actor component, and it already has a tick available, right? Let's go ahead. We're just going to run it in the loop. Now, if we don't specify a time, like tick interval, right? If we don't specify a tick interval, then if the tick interval is set to 0, then this will tick every frame. So if we're running 30 frames a second, it will tick 30 times a second. If we're running 60 or 120 frames a second, really high, which, you know, and you might want that for certain things, but for something like a health where we want it to be over a very specific time, we want to, we want to make sure we want to change it so that we want to change the tick component so it runs, it only ticks every 0.2 of a second, or whatever we've set in generation time here in the character's generation time. So what we do is we'll use the function set component tick interval, and it's just part of the function class. So as you can see, set component tick interval, that's the one we want, and that's where you specify your time. And by specifying the time amount, we can then specify how often we want this to fire. So this will give us a nice clean time loop. And then on starts, we're also going to say, okay, enable the tick. Once this is set to enable and set to true, tick component will start to fire and it will go on. All right, so now let's work on our facade functions. So these are the functions. So as you know, each one of our vitals has its own implementer methods. So rather than duplicating this 4 times or 5 times or 6 times, depending on how many core vitals you have, what we're doing is we're just going to have one set of these functions, and we'll let the enumerator determine what we're going to access. And to do that, by using an enumerator, we can then run a switch function within there. So I have already got this kind of written out, so we'll just go ahead and put the switch in. So by type, the type is the enumerator type. Here's our, each case is an enumerated case, and then we're just, for this function, since we're returning, we're just going to either return health, stamina, sustenance, energy. And by default, I've got a default of false. That way, if for some reason we added another enumerator up here, but we forgot to implement it during development, it won't get, we won't have it, the application, crash because it's trying to return something that's not there. So by default, we're always going to, I like to always return false. You could also, have it output to a log file as well. I'm not going to do that for this demo, but you could also do that. So this just allows us to now cleanly access the isFull functions on each one of these core vital components of our character vital. Same now, or we're just going to do the same thing for isEmpty. Core vitals is empty. Again, the we're going to take in the enumerator type. We're going to test our enumerator type against, and from there we'll pull out just the opposite of isFull. We'll pull back the isEmpties. Is enough. We'll do the same thing here. Is enough. I will just go grab all that switch code. Switch type, health, and here we're actually going to say find it by the enumerator type, and then we're going to add the cost in there, and it will check to see if it's enough and return it. So nice simple little switch, just trying to keep things nice and clean. Then we'll go do the same thing for increase current. Yeah, and you can kind of see that there's a pattern here. Again, enumerator type, switch, it's just rinse, repeat, rinse, repeat, rinse, repeat for each one of these. Nothing fancy. Now, for decrease current, we're going to do something a little different. So as you know, we have those protected variables up top, or protected functions up top. Which have our game, we've added a little bit of game logic there that we want to standardize. So instead of just decreasing the health raw like we are with stamina, we're going to pass it through the decrease health function instead. And the same thing for decrease sustenance. If we call this outside of the loop and we want to decrease sustenance, it will then go ahead and check that rule. Otherwise, there it is. And almost done. We're almost done with defining the components. Just got a couple more switch variables to do, switch functions to do. So let's go ahead and add that one in. So this is our regeneration flag. So this is how we want to if we want to turn on and off regeneration within the code during game time. So again, we can decide which one we want to turn on and off based on the value. And last but not least, the most important one, which is get %, because we want to be able to then show it in the bar. So let's go ahead and do that. And so we've got get %, core, vital, and type. So we have the health, stamina, and all this does is it's just going to go ahead and bring the %, and if we don't have it defined, but that should define all of our component variables within the code. And just to make sure that everything's happy, we'll go ahead and compile. Nope, Unreal Engine's not happy. Oh yeah, that's because I made a mistake. As I said, you know, always make sure that your generated.h file is the last to be there. So, oops, my bad. So, gone ahead, we've moved that up top. We'll just go ahead and minimize. We'll run it again, and hopefully, and yes, it's all happy. So I'm going to stop the video here, this video here on how to build a component. In the next video, I'm going to go ahead and implement the core component within the blueprint. So this will be it for C++ side, and then we'll move over in the next video to scripting this component together so that we can see all those progress bars in action. So thank you for bearing with me during this tutorial, and I'll see you on the next one.